Hello students, today we are going to discuss about Archimedes principle. This is fluid pressure of fluid part 2. Fluid pressure part 2. Our first topic is Archimedes principle. According to Archimedes principle, when a body is immersed, partially or fully in a liquid, it experiences upthrust or buoyant force, which is equal to the weight of displaced liquid. It means जब हम किसी भी बॉडी को किसी लिक्विड में किसी फ्लूइड में, लिक्विड मीन्स लिक्विड और यहाँ पे हम फ्लूइड वर्ड यूज कर सकते हैं, लिक्विड एज वेल एज गैसेस, जब हम उसमें डिप करते हैं तो बॉडी के ऊपर एक अपवर्ड फोर्स काम करता है, दैट इज कॉल्ड buoyant फोर्स and it is also called upthrust, and the value of upward force always equal to the weight of the displaced liquid, or we can say weight of the displaced fluid. इसका हम प्रूफ कर सकते हैं. Proof of Archimedes. Let this is a beaker full of water, and a cylinder of cross section A, cross section is A here, and it is also A. Pot is full of water. The height of liquid over the top is h1. This height is h1 and bottom is h2, and the height of cylinder is h. Then the downward force, it means force due to water column on the top. Here pressure due to वाटर कॉलम, ऊपर का ये जो टॉप है इसके ऊपर एक वाटर कॉलम बनेगा, वाटर कॉलम ऑफ h1 हाइट. तो प्रेशर ड्यू टू वाटर कॉलम ऑन द टॉप ऑफ सिलेंडर इज P1 is equal to pressure P is equal to H rho G. So here height of water column is H1, rho and G, where rho is the density of liquid. This is first equation. So that the force due to water column on the top, F1 is equal to P1 into cross section of the cylinder, and F1 is equal to H1 rho GA. This force is downward force because water column is upward on the top, then this force is downward force. Now pressure on the bottom of the cylinder, it will be P2 is equal to H2 because depth of water is H2 at the bottom, and rho and G, and it will be upward force. This is upward force. F1 is downward force. F1 is downward force and F2 is upward force. Pressure P2 and force on bottom F2 will be P2 into A. Here A is also the area of cross section. H2 rho G into A. This is third F, and it is upward force. This is upward force. The resultant force will be, because F2 is greater, H2 is greater, that's why F2 is greater. F1 is H1 rho Ga and F2 is H2 rho Ga. We know that H2 is greater than H1, that's why F2 is greater than F1. It means resultant force will be the upward force. Here the resultant force F will be F2 minus F1, that will be upward force because F2 is greater. Because F2 is greater. So that F is equal to H2 rho Ga minus F1 is H1 rho Ga. It is equal to H2 minus H1 because rho Ga is common. Rho Ga is common, and F is equal to H2 minus H1 is H, that is height of cylinder, rho Ga. This is the resultant force in upward direction, and this is buoyant force. So here F is equal to H and A is V, volume of the displaced liquid, H and A, rho G. Here H and A is V, V rho G, because H into A equal to volume V. Here volume of cylinder, because cylinder is completely dipped into the liquid, so volume of cylinder will be equal to the volume of we have to prove this force will be equal to the weight of the displaced liquid. So here this force is due to the water column, and it is in upward direction. So we know that V is the volume of cylinder, and rho is the volume density of liquid, G is gravitational acceleration. We know that volume of cylinder is equal to volume of displaced liquid. So that the buoyant force and volume of displaced liquid and density of the liquid will be the mass of liquid. So that mass of liquid will be equal to volume into density of liquid, that is equal to m, and weight of liquid, weight of displaced liquid is equal to mass into m into g, that is equal to v rho g. It means the upward force here, this is the buoyant force in upward direction, and this will be equal to the weight of the displaced liquid. It is also equal to the rho v rho g, both are equal, so that we can say the buoyant force जो हमने ऊपर निकाला है, and will be equal to the weight of the displaced liquid, Now our next topic is practical proof of Archimedes principle. Proof of Archimedes. इसके लिए हम क्या करें कि first we take the spring balance. A body is suspended in air. Let it is at this reading. Arrow shows the reading of the spring balance. Upper point is 0. It may be 40, 20, 60 something. And arrow shows the reading. This is the arrow. It is weight of the body in air. Let this reading is W1. Weight of the body in air is W1. In second part, this body is dipped. Same body, it is dipped into the water. At this time, its weight, this is 0, this is 20, this is 40 and 60. So here W2 is weight of the body in the liquid. Let it is W2 in third part, and this water, this displaced water is taken into a beaker. Initially it is full of water. This pot is full of water and displaced water taken into the beaker. This is displaced water. Let initial weight of beaker is W3. This is beaker. Initial means empty, when beaker is empty, and when displaced water is filled in the beaker, its weight becomes W4. एम्प्टी वाटर का यदि हम वेट लेते हैं वो W3 है और डिस्प्लेस्ड वाटर का W4 है. डिस्प्लेस्ड वाटर विद बीकर टोटल वेट इज W4. सो वी कैन सी द weight loss of the body in liquid. Initial weight of the body in air is W1 and weight of the body in liquid is W2. So weight loss of the body in liquid will be W1 minus W2, and weight of the displaced liquid, it is the weight of beaker plus displaced liquid minus the weight of the empty beaker. It will be equal to W4 minus W3, and experimentally we find that the W1 minus W2 always equal to W4 minus W3. It means weight loss of a body in the liquid will be equal to weight of the displaced liquid. It means buoyant force always equal to the weight of displaced liquid. It is equal to the buoyant force.